Okay, I'm going to talk to you about choices that have to be made when you start moving to the x86 platform. And as always, we are here to help you protect the investment you have made in your applications. And we believe that moving to x86 is the best way to do that. We're going to talk about choices in the area of virtualization, hypervisors, hardware, virtual machine devices, and clustering and shared storage. So a little bit about OpenVMS and virtualization. We want to run on those hypervisors that are most commonly found in both the data center and on the desktop. With that, we strive to be as independent as possible from the underlying hardware. In our mind, it shouldn't really, once you're on x86, it makes no sense to tell people you're tied to this specific hardware platform. Whether you're running on HPE or on Dell or on IBM or Apple, it should all pretty much work the same. We also want to make OpenVMS available in at least one prominent public cloud service. And as you've heard this morning from Rafael and Adam, we've actually gotten there. So this is one target that we achieved, I think, even sooner than we realized we would. And to sum this up, we don't want OpenVMS to be that one system that still requires a dedicated box in the data center. If everything your company does runs on virtual machines or in the cloud, which is increasingly the case for companies, having a system that needs to be a specific bit of hardware somewhere in the data center all by itself with no use other than running OpenVMS is not what system administrators want to see. At least it's not what CIOs want to see. So you have some choices to make. So when you choose a hypervisor, you can choose between two different types of hypervisor. There is the type 1 hypervisor, which runs directly on the hardware. Also, other names for this are native, bare metal, and this is the type of hypervisor that you typically find in the data center. So examples of this are VMware vSphere for ESXi, KVM, and some people think that KVM is not a type 1 hypervisor because they believe it runs on Linux. Reality is a little bit more complicated. KVM is a module inside Windows or inside Linux that, when it's activated, inserts itself underneath the operating system and turns Linux into a guest on a type 1 hypervisor. And then you use that Linux system to manage the hypervisor and the other systems that run on it. But the other systems run on KVM. They don't run on KVM on top of Linux. And then there's also Xen, and there's Microsoft Hyper-V. And the ones that I've put in bold are the ones that we support on OpenVMS. There's also type 2 hypervisors. These are hypervisors that run on top of a regular operating system. So these are the types of hypervisors like VirtualBox or VMware Workstation that a developer would run on their desktop computer or on their laptop. There's also Microsoft Virtual PC, and of course on Integrity, we had HPVM, which was a type 2 hypervisor for the data center running on top of HPUX. I don't think it was very popular. But I put HPVM in the list to show you that OpenVMS isn't completely new to hypervisors. And you could almost argue that Galaxy on Alpha had some hypervisor-like functionality.
Yes and no.
Yes and no. Some yes, some no. So with these, like the ones in bold are the one that we support on OpenVMS, and I'll go into one of the other ones a little bit later. But let's try and take a look at what some of those differences are. So VMware ESXi, of course, it's a paid product. It's not open source. It's once you get a hang of it, it's pretty easy to manage. VMware ESXi has a somewhat short hardware compatibility list. There are systems from pretty much any vendor on there, but certainly not every system ever produced. And systems tend to drop off the list of what is supported in ESXi in newer versions somewhat aggressively. So VMware tries to keep this list manageable. Maybe I should go to the other ones as well. So if you have Red Hat Enterprise Linux with KVM, which is one of the 2 KVM flavors that we support, it's free and open source software, but Red Hat makes it difficult to really get it for free. For most use cases, you'd want to get a paid subscription from Red Hat. And then there's the Oracle Linux KVM, which is based on Red Hat, so it's also open source. Oracle makes paid support available, but they do provide everything, including patches and bug fixes and all their software for free if you're willing to forego support. If you do get support, it looks like Oracle support is slightly less expensive than Red Hat KVM support, and both of them are less expensive than ESXi support. I talked about how VMware ESXi is pretty easy to manage. I would say that the same goes for Oracle Linux KVM if you use the tools that Oracle provides with that. And Red Hat KVM is catching up with that. But I find Red Hat KVM to be a little, you tend to need to use the command line a few times more often than you do with the other 2. Red Hat and Oracle Linux have a pretty big hardware compatibility list. Pretty much anything you can run Red Hat Linux on supports Red Hat Linux with KVM. And Oracle Linux, in Oracle Linux, you have 2 choices of Linux kernel. You either run the Oracle Enterprise kernel, which has a more limited hardware compatibility list, or you run the original Red Hat kernel in Oracle Linux, in which case the hardware compatibility list is the same as that for Red Hat KVM. So if you have an older system lying around, modern versions of ESXi most likely will not run on that, or at least not be supported, whereas the KVMs will most likely be supported on that system. During some measurements, I find that KVM, on average, has a slight performance edge over VMware ESXi. What VMware is really good at is doing things like disaster tolerancy, where you can cluster VMware nodes together and like do live migrations of your data, live migrations of your virtual machines, and it's all, if once you've got the system set up correctly for that, it's literally a few clicks of a mouse to move a system. And you can also set up things so that you, for instance, say that one of your VMware nodes needs maintenance. You can set things up in a way that you click a button that says, I want to take this node into maintenance, and all the virtual machines that are on there get moved to different places, and it looks at like where the load is the lightest to figure out where to move those things. That does require the most expensive license you can get for ESXi, though, which after the Broadcom takeover is something that you might want to look at what that cost is. Red Hat Linux KVM, you can do this sort of thing, but you require additional software, and it's a little more work to set it up, a little more manual work. It can be done, and then Oracle Linux KVM, they have built this package where they've combined these little bits and pieces that you would need on top of KVM to make this sort of orchestration possible. And they've included it with the product. So there it's getting close to the experience on VMware ESXi. Looking at the type 2 hypervisors, I will compare VMware Workstation and Fusion, which is the same product but for the Mac, with VirtualBox. Again, VMware is paid closed source, although that paid isn't true anymore. It is now free. I think that was changed sometime last year. I should have updated my slides. I missed this one. So they're both free, but of course, VMware is still closed source and VirtualBox is open source. Although if you want to use USB generation 3 ports on VirtualBox, or if you want to do some other special things, you need to buy an extension kit, which is not open source and for which you do need a license if you use the software commercially. Here, VirtualBox performance is not so great. If I compare it to VMware, VMware's performance is noticeably better. VirtualBox, I think, still hasn't solved the nested virtualization issue if you're running on a system that runs Windows and you use anything that uses the Hyper-V subsystem, which with Windows 11, it's getting pretty difficult to completely get rid of all the Hyper-V components because it's used for some of the security features in Windows 11. So even if you never plan to run virtual machine, you can set up a laptop with Windows 11, chances are that that virtualization layer is enabled to enable things like virtualization-based security and like code isolation. Workstation is a bit easier to manage, but the graphical interface for VirtualBox is almost as good. Question we get sometimes is why we do not support Microsoft Hyper-V. And this is really a big difference in how Hyper-V works. And for example, pretty much any other hypervisor provides emulated devices and emulated controllers. So if you have an operating system that knows nothing about virtualized hardware that was written to use a real SCSI controller with real SCSI disks, other hypervisors provide emulated SCSI disks and emulated SCSI controllers that look just like the real thing to the operating system. That means that you can boot an operating system using the device drivers that that operating system also uses to boot on real hardware. These hypervisors also sometimes optionally provide a virtualized I/O interface, which generally has higher performance, and there are good reasons to use them. But the point is, you don't need to completely develop a whole set of these virtualized drivers before you can start booting and debugging your operating system on one of these hypervisors. Hyper-V is different. Hyper-V doesn't provide an emulated SCSI controller or SCSI disk. It doesn't provide a emulated Intel network card, at least not in Hyper-V Generation 2 virtual machines, which is the generation that is needed to get the UEFI firmware that we need. They only provide these virtualized I/O interfaces, and Microsoft's virtualized I/O interface differs from like the industry standard VirtIO interface that is used on KVM, and it's different from the VMX virtualized interface that VMware uses. That means that before you can even boot anything on Hyper-V, you need to have already developed these drivers. And it's a chicken and egg story. May we get there one day? Perhaps, if there's a sufficient market for Hyper-V. We're not quite seeing the demand to run on Hyper-V. And right now we have better things to focus our engineering efforts on. If you do want to see OpenVMS run on Hyper-V, make sure that we know about that so that we keep like a running tab of customers that want to be on Hyper-V. If no one speaks up, it will never happen. When it comes to the choice of which KVM to pick, Red Hat or Oracle, one thing to consider is the Oracle licensing scheme. And I cannot say anything for sure about how Oracle plans to license Oracle RDB on x86. I do know how Oracle licenses the Oracle Classic database products on x86. And Oracle makes a difference between running that on their own hypervisor versus running it on any other hypervisor. Oracle says if you have a host system with, say, 256 CPU cores, and you run a virtual machine that has 8 CPU cores on that system, you run Oracle on that, you need to buy a license for the host system for all 256 cores. Unless you're running our hypervisor, in that case, if you enable the option to tie the core in the virtual machine to a specific core on the host, then you are allowed to buy a license only for those 8 cores that you have in your virtual machine. Again, I don't know whether this is what Oracle will also do with Oracle RDB, but it may be something to consider.
A small note, if you do this CPU pinning, and you're not able to live migrate this again.
Good point. Yes, this CPU pinning prevents live migration from happening. Very good point. Some security considerations. This is almost self-explanatory, but no virtual machine is more secure than the hypervisor itself. If you give someone administrative access to your hypervisor, it's the same as allowing someone physical access to your Itanium server. Perhaps the most important thing to secure is access to the VMS console port, OPA 0, because if someone who shouldn't gets access to that, they hit Control-P, reboot your system, set the flags to boot in conversational mode, and they can do whatever they want. Wipe out your system disk, change your system password. make sure that that console connection is secure at all times. Good ways to secure it are to use the SSH protocol, to use a pipe, or to use our guest console. Do not simply use a telnet port that is open to the entire world. Any questions on the hypervisor part? Yes.
Those desktop on my Mac and get very far. Is there any reason why?
We haven't done any tests with parallels, but I don't know if that is KVM based or supposedly it's probably not. No, it can't be, of course. It's just a hypervisor we do not support. And there may be all sorts of reasons. Most common reason is maybe that the UEFI standard is like, it's called a unified standard, but the unified is in quotes, I think, because every vendor and every hypervisor manufacturer has a slight variation on what we get presented with. So if you try to boot VMS on a hypervisor we've never seen before, chances are pretty high that it will fail. And sometimes it's easy to fix, sometimes it will be a whole lot of work.
Is SSH supported for ESX? Console?
You have to go through some sort of jump box to set that up. So what I would typically do is like set up a second virtual machine running something like Linux on the same system, create a named pipe between the two virtual machines for that serial port traffic, and then you SSH into the Linux box, connect to that serial port, and then you have your console. And then you
connect it to telnet from that.
No, you don't use telnet, you use a named pipe. Yes, in ESXi, you can, instead of like having a network connection to your serial port, you can have a basically direct sort of like through memory connection to another virtual machine, which is completely secure. It's just a bother to set up. I don't know that they support like an SSH direction into an emulated serial port. I don't believe they do. I do believe they support Telnet S, which is Telnet over an SSL encryption layer. But then you have to deal with like certificate management and things like that by yourself. All right. I didn't catch all that, but if you don't mind, I'll move on to the next section. Choosing your hardware. So the whole point of a hypervisor, 2 points to a hypervisor. One, you can run multiple systems on a single host. But maybe as important, or even more importantly to us, the hypervisor hides most of the details of the underlying hardware from the operating system. So we have run OpenVMS using ESXi and KVM on numerous different systems. Oh, sorry, the ice cream was too good, I think. We've run it on numerous systems from various different manufacturers, both in our lab, but also developers who had a brand X system at home that they decided to try it on. And it really is like, as long as the CPU has the support that OpenVMS needs, you can make VMS run on a 64-bit system with KVM or with ESXi. Pretty much all the major manufacturers, any manufacturer that you could probably think of, has systems that appear on the hardware compatibility list for ESXi. as well as the hypercompatibility list for Red Hat KVM. So which one do you pick? You can basically choose whatever brand you're most comfortable with. If your entire data center runs on Dell systems, there's no reason for the OpenVMS system to be different. But there's one exception. If you use shared storage, or if you use fiber channel storage, then we only support certain HVAs. The reason for that is when you use fiber channel in a virtual environment, you need to use fiber channel pass-through. And if you use fiber channel pass-through, it means that the PCI card, the HVA that connected to your fiber channel network, is seen directly by the OpenVMS operating system. That in turn means that it cannot work if that is a card that our driver does not support. We do not have the resources to create drivers and, more importantly, to do the qualification testing on fiber channel cards from a dozen different vendors. And would it technically be possible? Of course. We could support, we could make OpenVMS run using a Dell fiber channel card, or using this Cisco hyper-converged infrastructure that does both Ethernet and fiber channel in the same card. We could do it, but if we ended up spending all our time developing those drivers, nothing else would happen. So we put a stake in the ground and we said, it's going to be the HPE cards that we are familiar with, that we have supported on Alpha and on Itanium. And we're going to do like the newer generations of those cards, but that's it. And we were the first few customers that we tried that message out on. We went in there with a little bit of trepidations because we had customers who had come to us and were like, yes, our entire environment runs on Dell and we just got rid of HP. We really don't want them in our data center besides Dell because we prefer dealing with a single vendor. And what we eventually want to do, and I'm going to show you how in a few minutes, is we eventually want to get back to that point where it doesn't really matter what you run on. But to get to that point, we need to invest our engineering resources in terms of storage controllers, in terms of device driver writing in that area. We want to focus on those things that will take us to the place where it doesn't really matter anymore what hardware we run on. And developing drivers for all the different vendors that are out there would really detract us from that mission. So if we did that, then the truly vendor agnostic stuff would not happen until much later. And with that messaging, we managed to convince most of our customers that this was, in fact, the right way to do things. So how do you, now that it doesn't matter whether it's an IBM or an HPE, if you don't have fiber channel, how do you pick the most important thing in your system, the processor? Do you want an Intel or an AMD processor? We have tested VMS with both. We had to do a little bit of work to support AMD processors after we had initially been developing exclusively on Intel processors, but it wasn't that much work. And pretty much every processor produced by either Intel or AMD over the last decade or so has all the basic features that OpenVMS needs to run on. If you pick a more recent processor, however, a processor that came off the assembly line yesterday has certain features that a processor that was produced 10 years ago did not. There may be some instruction set extensions, there may be some other changes. And we found that there are some extensions to the instruction set and other new features in processors that we can leverage in OpenVMS to have better performance on these more modern CPUs. A good example of that, for instance, is PCIDs, process context identifiers. In OpenVMS, because OpenVMS is a 4-mode operating system, that we need to squeeze onto a processor that really only has 2 modes. To the processor, a single OpenVMS process looks like 4 different processes with 4 sets of page tables. That means that every time when we change modes in OpenVMS, it looks like a process context switch to the processor in terms of the page table usage. PCID is a technology where you can tag page tables with a process identifier, and that allows the processor to remember the translations for that process after a context switch, rather than having to throw everything away. On OpenVMS, a context switch on a processor that does not support PCIDs takes more performance away than it does on a processor that does, because you're not constantly refilling all your translation buffers. And the way we managed to do that, if you have a version of VMS prior to version 9.2.3, you will see that there are different system primitives images on your system. There's a system primitive 0, a system primitive 1, system primitive 4, and all these are different variants of that image that use different features of the processor. With version 9.2.3, that's no longer really visible to the user because we've managed to compress all those different routines into a single image. It's like a fat binary. But there are still settings in sysgen where you can play with which processor features do I want VMS to use and which do I not want VMS to use. So it pays to buy a more modern processor. In terms of cores, OpenVMS, we officially support up to 32 cores in a single virtual machine. The support is in the operating system, the code is in the operating system to go up to 64, but we haven't done enough testing with more than 32 processors to be confident that we can actually support that. So don't go over 32 cores.
Hey, Camiel,
Yes.
our preliminary testing shows that anything above 16 on a virtual machine is not good.
Well, that really depends on your workload.
Well, Claire's testing was pretty conclusive with his workload, but I agree, it may vary by workload, but the performance plummeted. It started degrading a bit, but then it hit a really bad point at that was 20. But after 16, it was noticeable.
We should probably, when we have done a bit more, we should probably do a presentation about that. But sure, throwing more cores at a system is not always an answer to solving performance issues. There are workloads where performance stops going up or even starts going down a bit because of synchronization overhead if you scale it beyond 4 cores. Other processes, you get there maybe with 10 cores. I think we have seen some workloads where we could scale up to 32 CPUs, but your mileage may vary. It's more cores is not always better. Choosing virtual machine devices. You can have different sorts of devices in a virtual machine. The most common are emulated devices. When you start out with a virtual machine, this is typically what you use. So you have a hypervisor that provides an emulation of a device that exists in real hardware and tries to make it look like it is hardware to the operating system. So for instance, you have the Intel E1000 NIC in your virtual machine, or you have a SATA controller with some emulated SATA disks, or a SCSI controller. Another type of device is a para-virtualized device. This is sort of like an emulated device, but it's an abstract interface that doesn't exist in reality. And this way, what you can avoid, for instance, is buffers being copied around. Typically, a physical device has its own buffer, and then you need some mechanism like DMA or programmed data I/O to fetch the data from the device's buffer and bring it into your system buffer or your application buffer. With a para-virtualized device, you can give the hypervisor a virtual address in your virtual machine, and the hypervisor will do all that heavy lifting for you and basically copy the data directly where you want it, rather than to a place where it then needs to be copied from again. So you can get some better I/O performance using these para-virtualized devices. Of course, they do need driver support in the operating system to be able to use them because the interface is so different. You can also have raw devices, which is, for instance, you have a physical disk or a physical DVD-ROM drive that you offer to your virtual machine using an emulated disk controller. So it's a physical device connected to a virtual machine, but going through something that's emulated. And then finally, we have these pass-through devices for PCIe, but it also exists for USB, where you have a physical controller that is exclusively reserved for use by a particular virtual machine. And all the hypervisor needs to do, this needs some support in the hardware, but that support is available in modern processors. But the hypervisor basically sets up a table in the chipset that says, if this device now belongs to that virtual machine, go through these translation tables to do all that. And once it's set up and your virtual machine is started, it's really transparent where you talk to that controller on the SCSI bus like it's in a physical machine that you're running on. And that brings me to clustering and shared storage. So this is back in the version 9.2.1 days. This screenshot was taken. So this is a cluster that has alpha, titanium, and x86 nodes in it. In fact, this is our main development cluster, XVMS, where the base operating system is developed. So we've had x86 nodes in that cluster for quite some time. Now, in version 9.2.1, we didn't have the capability to talk to fiber channel devices yet. So before version 9.2-3, you could cluster with alpha and titanium nodes, but shared storage is only supported if you use MSCP. So the alphas or the titaniums are directly connected to the disk. The x86 systems need to go through those systems using MSCP. One of the questions that came up sometimes, couldn't you have like a raw device, present it to two different virtual machines and build a cluster using shared storage on x86 that way? Or could you use shared writer virtual disks? And there's an issue with that, that TCQ, tag command queuing, is not transparent. And TCQ transparency is something that the VMS clustering protocol needs to be able to share disks And there's one thing that's pretty different between how OpenVMS deals with shared disk devices compared to pretty much any other clustering software. And that is that on a VMS device, a volume is accessible to multiple nodes at the same time. And every node can write to the same disk at the same time, because we have our log manager that is much more fine-grained than the solutions that other clustering solutions provide. To make that work properly, we need to make sure that disk access across a cluster can be synchronized properly using TCQ. And if that doesn't work, we cannot reliably run a cluster. With version 9.2-3, we added support for fiber channel using a technique called PCI pass-through, or VMware calls it VM Direct I/O. Version 9.2.3, we only support fiber channel on VMware vSphere ESXi. Because it requires talking directly to a hardware device in the host, it means you cannot do a vMotion, because when you move the virtual machine across, that piece of hardware is going to stay where it was. No cloud provider will put a fiber channel controller in a host system in the cloud form. So in the cloud, you cannot use this technique. It requires a dedicated HBA. That HBA has to be this HP SN1100Q 16 gigabit fiber channel card. That's the only one we supported in 9.2.3. That card then requires HPE Gen 10 hardware. It does not work in the newer Gen 11 hardware. Boot is not supported, and you need to use a storage array that's on our approved storage array list, which is the same as for Itanium. Now, this is the situation today. With VMS version 9.2-3, which 9.2.3 update 2, which we plan to release in July, we're going to expand the fiber channel options you have. So in addition to VMware vSphere, we're also going to support PCI pass-through on Red Hat Linux and Oracle Linux with KVM. There again, live migration, where you move one virtual machine to another host, not supported. Besides the 16 gigabit fiber channel HBA, we're also going to support two flavors of 32 gigabit fiber channel HBA, the SN1600Q and the SN1610Q. And those cards are compatible with the HPE Gen 11 hardware. And that means that you can get the newer HPE Gen 11s. Of course, now that we're announcing it, HPE has just released their Gen 12 platform. These cards will most likely also work on the Gen 12 platform, but we don't have that hardware in our lab. HPE would love us to get it, but the prices they are quoting us for that are, right now at least, are prohibitive. But this may come in the future. And the rest is still the same. Now, what we're really working towards, and this is why we're only supporting these very specific HBAs and not doing a lot of driver development for other fiber channel cards, is that with version v9.2.4 of OpenVMS, we want to support a storage protocol called iSCSI. And iSCSI is SCSI over TCP/IP. So fiber channel is SCSI over fiber optic cables, but it's still dedicated hardware. iSCSI is SCSI that runs on top of the standard network stack. Of course, you want some performance, so you likely want a fast network card for iSCSI. You also probably want to separate your iSCSI traffic from your other network traffic, so have a dedicated storage network for that. But the nice part about iSCSI is that it is supported by the network cards that are part of these hypervisors. So This will work with all the hypervisors we support. vMotion and live migration are possible with this because it's just the network. And maybe best of all, this technology will work just like that in the cloud. If you're on the Oracle Cloud, you can provision iSCSI storage there and could connect to it from your open VMS systems natively once we have this capability. All the hardware restrictions on the host, other than like the CPU needs to have these capabilities, but anything that says it has to be HPE, that is gone with iSCSI. Still no boot support, and for now we are only planning to do this for x86. We will evaluate whether it's feasible to do this for the other platforms once we get it going on x86. Post version 9.2.4, we plan to add boot support and cluster common system disks. So to recapitulate, and this is my last slide, 3 different ways to connect to shared storage from x86. There's MSCP, which is available now, but it's a little slow, and if the system that you go through to access your disk goes away, you no longer have access to the disk. If you use fiber channel pass-through, it's available now, but you have to be on HPE hardware, and vMotion is no longer possible. And then with iSCSI, which we plan to have in version 9.2.4, which we've planned for mid next year, then those limitations go away. But certainly for the first time, it's going to be x86 only. Later, maybe we'll add the other platforms. And I think I have about 1 minute left for questions. I have 4. Okay, I did better than I thought.
No, she has 4 questions.
You have 4 questions. Okay. They're in the back.
Yep. Maybe you showed a lot of virtualization. This question comes from an old-fashioned system administrator. Is it possible to run x86 on bare metal?
If you provide us with a good business case where we are sure that we can recuperate the kind of investment that would be needed to support a specific bare metal platform, then we can talk about that. But so far, the business case has not been presented to us. We thought we got close once. We had let me see how I can talk about this without giving away who the customer is. So we have a company that makes equipment. And as part of this equipment, they sell an open VMS system. And this open VMS system controls the device that they built. And they were interested in going to x86. They were previously interested going to a Windows-based solution. They actually got some of their customers to Windows and then started getting caught in update hell. So they would rather not move the rest of their entire customer base to their Windows-based solution. They would like to go to x86 with us. But they were concerned about running on a virtual machine because they have some pretty tight, like, timing requirements for the software. And their first experiments with OpenVMS and x86 weren't all that hopeful. We got some of our best people on this problem. Robert Nydal, who's sitting there, knows exactly who I'm talking about. And we managed to configure the host system and tweak the virtual machine hypervisor and do some tweaking to OpenVMS itself to bring the numbers that we can have on x86 on a hypervisor down to about the same level as they were on Itanium, which is what the customer was used to. And when we started showing a little bit, we were actually quite far in our plans to start working on support for bare metals. But once we were starting to show some results in getting like a little closer to what the customer needed, the interest went away. And now it's not even a subject of conversation with that customer anymore. The big drawback, of course, of being on bare metal is that the life cycle is so short for hardware. HPE will release Gen 11 this year, and 2 years from now, they'll release something new. And it will have a different chipset, it will have a different fiber channel control, and we would have to do all that driver development again. That really is a game that we would like to get out of.
Not just business case, it's also continuous financing of that investment.
It's the business case, but the business case needs to work in the context of then having to do a whole lot of work, not just once, but every time there's a new generation of hardware. And that's tough to find. Yeah.
How about the NFS?
Well, NFS for shared storage, sure. Big difference between NFS and something like Fiber Channel or iSCSI is that NFS is a file system. So you share storage at the file level or at the file system level, not at the block device driver. So you can use that to share storage between systems, but if you're talking in the context of a VMS cluster with shared storage, we need a block device. Yeah.
Have you done any testing with hyperconverged systems?
Not really, no. We've looked at some of these hyper-converged systems, but what you run into is that what looks like fiber channel isn't really fiber channel. So the controllers are different, so we have to do some driver development for that. With iSCSI, there's a good chance that could work just out of the box if the hypervisor supports that. If the hypervisor supports that hyperconverged solutions, then we can run on that. I'm pretty confident that we can run on that without issue once we have iSCSI. All right. Thank you, everyone, and I think we have another 10-minute break.